Hello everyone, this is Group 10 and I am Sharanya Chakraborty. Our project for this DIY course is a retro Arduino ping pong LCD game. As you can see, this is our setup of the project. The main parts of the project include the Arduino Uno microcontroller, this LCD 16:2 display, these 5 buttons which are for various purposes which I'll explain later, this potentiometer and a piezo buzzer of course. So as you can see, our game has started. This text indicates that now we have to press the start button to start the game. So let's start the game. Player 2 this side, player 1 this side. I use the up button to move that paddle up. Another player uses the corresponding buttons to move that paddles up. The scores are getting updated each time the ball hits the paddles. And as soon as you miss the ball, the game is over and the other person wins. Now I will use the potentiometer to change the brightness of the screen. As you can see, this is increasing the brightness and this is decreasing the brightness. So now I will show you the circuit diagram of this project. This circuit diagram was created using Tinkercad, as you all can see. All the main components and their connections have been cleanly drawn here. But since there are so many connections, I'll just explain the connections of the LCD screen, and the rest can be easily understood through the code which I'll explain later. Now let's look at the LCD screen. If you look closely, there are many ports on this LCD screen, and the first one, as the name suggests, it's the ground port, and it has been connected to the ground terminal of the breadboard, which is in turn connected to the ground of the Arduino. Next, we have the VCC or the power unit, which has been connected to the 5-volt source of the Arduino through the breadboard. This is the contrast or the VO pin. This is used to change the brightness of the screen, and hence it has been connected to the potentiometer, as you all can see. Then we have the RS, that is the register select pin. This has been connected to a particular port of the Arduino. Then we have the RW or the read and write, which has been connected to the ground. And finally we have the E, which is the enable pin, and it has been connected to a separate pin of the Arduino. These were the main pins which need to be connected whenever you use an LCD with an Arduino. But next we have used this LCD in the half bit mode, and hence you will see that out of these 8 ports from DB0 to DB7, we have used only 4 ports, that is DB4 to DB7. These have been used to code the various characters and the movements that have been defined in the code. And finally, these last 2 pins, LED anode and LED cathode, have to be connected to the power source and the ground respectively, as per the specifications. A picture of the circuit diagram will be attached in the video description. You can also easily edit these circuit after following it from the picture and making a recreation of this on Tinkercad. Actually, 2 breadboards weren't necessary to complete this project, but since we had to, space out the wires and make the project look neat and clean, we used 2 breadboards. So these are the materials which we have used while creating this project. We have an Arduino Uno microcontroller, which is the main component which will store all the codes and will give necessary instructions to print the important characters on the LCD screen through the flow of signals. Next, we have the 16:2 LCD display, which is the main component of the game, as you have all seen, and it will print the various components of the game. There are 5 push buttons, each with different functions, as explained. One will be for start, and 2 for each player for up and down movements. The resistors will control the amount of current flowing in the circuit so that the circuit doesn't get overheated. Jumper wires will serve connections, and the breadboard will be useful in evenly distributing the connections. The piezo buzzer is an important component which will play different sounds in different situations while the ball hits the wall or the paddle, or a player misses the ball and the game is over. And then we have the potentiometer, which controls the brightness of the screen as demonstrated previously. Now I will tell you about the silent features of the code which we have used in this project. First, I will go through the definitions. First, we can see that we have the include liquid crystal etch, the liquid crystal library, and it is used for all the LCD screens which are used in Arduino projects. The numbers inside the brackets 12, 11, 5, 4, 3, 2 stand for the different pins which I had shown previously in the Tinkercad circuit. 12 and 11 stand for the uh, RS and enable pins respectively, and 5, 4, 3, 2 stand for the D4, D5, D6 and D7 pins. Next, we have the definitions for the buttons and the piezo buzzer. The start buzzer is defined for the 13th pin on the Arduino. Similarly, the rest of the buttons are defined and the piezo buzzer also. The third one, these are actually byte arrays, which define the positions of the paddles on the LCD screen. So we know that it is a 16x2 LCD display. So it has 16 columns and 2 rows. But each column is also divided into 16 pixels. So as you can see, the middle 4 pixels are denoted by 1. So this works as a binary system. 0 denotes that the pixel is turned off, that is no display is shown at that point. And 1 suggests that the pixel will show a white point display on the LCD screen. So the middle 4 ones signify the 4 vertical positions of the paddle. Similarly, these definitions have been done for both the paddles. Now we have the ball array, which as you can see has only one in the middle of the array, which means that it is made up of only one pixel. Next we have some integers. X represents the horizontal position of the ball. Bounce may keep track of the bounces that have been made with the upper and the lower walls of the LCD display. And V1, V2, V3 are various temporary variables. The character direction represents the direction of the movement of the ball. We have L for left and similarly R for right. Score 1 and score 2 store the various scores of the two players. And finally, we have a boolean named game. When its value is 0, it means that the game is not running. But when its value is 1, it means that the game is already running. Next, we move on to the setup part of the code. First, there's the pin setup. As you can see, these various pins which had been defined earlier have been now set as input or output pins. Since we are providing input through the button pins have been denoted as input pins, and the buzzer, since the power will be provided by the Arduino according to the code, it has been set as the output pin. The LCD setup mainly consists of these two lines, LCD begin 16:2 and LCD clear. LCD begin 16,2 represents the 16 columns and 2 rows, and LCD clear ensures that there is nothing printed already on the board before the game has started. Next, the initial screen display setup. The LCD set cursor function is used to set the position of the cursor from where the printing of the text will start on the LCD screen. So 2, 0 means the second column on the first row, and 1, 1 means the first column of the second row. It is working according to a 2D array, basic 2D array. The various texts are printed, and the delay function displays the text for that particular amount of time. This is in milliseconds. So the first text, Arduino Uno Ping Pong game, will be displayed for 1500 milliseconds or 1.5 seconds. The next part of the code is the loop, which is very important because as long as the game is running, this loop will also continue to run. This is the first check in the loop part of the code. When the game is not running, represented by game is equal to 0, we initialize the positions of the paddles to their actual positions, which we have already defined in the definitions. So as to ensure that the paddles are in the required positions before the game starts. Same has been done for the ball. Next, we have the starting point of the game. The ball's position is initialized to 8, and a text appears on the screen saying press start button, which implies that as soon as the start button is pressed, the game will start. Next, we have the movement of the paddles using buttons. Digital read function, it detects when the button is being pressed. So when high represents a positive button press and low means when the button is not being pressed. So whenever the buttons are pressed, for example, let's take P1U button. P1U represents player 1 up or the paddle 1 up, whatever. So Paddle one up means when the button is pressed, the paddle will move upwards. Similarly, paddle one down will move the player one's paddle downwards, and that has been done for player two also. This is one important part of the code named the ball speed variation point. So for example, when two players are playing and they feel that the game has become too easy because the speed of the ball is too low, then they can manually change the speed of the ball by lowering the delay in milliseconds. Next, we have printing the scores. Printing the scores are basically printing the values of the two variables score 1 and score 2 after every time the ball hits the paddle positively. And the next most important part of the code is the collision detection, score updating, and buzzer sound. Basically, in this part, we are initializing the two variables v1 and v2 to the positions of the ball and the paddle respectively. It then checks whether v1 and v2 are equal, which means whether the position of the ball and the paddle are equal or the ball has collided with the paddle. If the collision has been detected, then the direction of the ball is changed to the opposite of the direction which it was initially moving in. For example, it was actually moving in left from the start as defined in the earlier definitions, and hence it has been changed to right here. And since player 1 has successfully returned the ball, the score of player 1, denoted by score 1, has been increased by 1. Also, the piezo sound 10 function denotes that as soon as the player returns the ball, a particular tone will be played. Next part, we have the game over. So when the player fails to hit the ball, the condition v1 equal to v2 will not be satisfied, right? So the else part of the code will come into play. The LCD will be cleared. The cursor will be set at a particular position and the message game over with the name of who won will be represented. Similarly, a different piezo sound will be played when the game gets over. The score variables will be reset to 0 and the boolean will be set to 0, which means the game is not going on right now. And then we have the ball movement part of the code. There you can see four functions here: ball left down, ball left up, and similarly ball right down and ball right up. So these are functions which have been later defined in the code and they define how the ball moves. So when the ball is moving towards left or right, as there are two parts in the code as you can see. So when the ball bounce is not detected, that is when the bounce with the upper or the lower wall is not detected, then the ball will move in a particular direction, that is up or down. Similarly, when it is moving towards the right. In conclusion, I'd like to say that this project was a really enjoyable one, and our team had a lot of fun while creating this. The DIY course gave us the perfect opportunity to complete this project. Though we ran into several problems while creating this project, such as getting the breadboard short circuited or the resistors blowing up due to excessive currents and wrong usage ratings, but still we completed this project. The code for this project will be attached in the description. For references, you can visit these websites. We use the Instructable website to start using the LCD display because we had no prior experience with it. This particular YouTube video named Using LCD Displays with Arduino by Droneboard Workshop helped us a lot in understanding the connections of the LCD. So if you are a beginner while using LCD, do watch this video because it explains the normal 16:2 LCD screen as well as the 16:2 I2C display. Thanks for watching.